Hello and welcome to another Lunch and Learn brought to you by CAD Dimensions. I'll be your host today. I'm Dave, and today's topics. Well, we're going to start with the 3D Sketcher. We're going to show you the general concepts of using the 3D Sketcher. We'll create a basic tube, which is really just nothing more than a swept feature. We're going to bring it into an assembly and position it, show it how you can get it from point A to point B. Then we're going to go a different route and create a similar tube in the context of the assembly, starting right from scratch. We'll go from start to finish in the context of the assembly itself, and then finally we'll wind up with doing approximately the same thing, but this time we'll use routing. And you do have to have SolidWorks Premium if you want to take the routing route, if you will. So to begin with, we will start out with a 3D sketch. You'll notice one of the first things right off the bat when you begin with a 3D sketch is that as soon as you start sketching anything, a line in this case, you notice that the origin arrows don't look what you're probably used to. They don't look like what you're used to in a 2D sketch. As you sketch, you'll notice what I like to call the virtual planes. Currently I'm sketching on the XY virtual plane. Now it's the YZ, and I can easily switch between these virtual planes by pressing the Tab key. So as you're moving the endpoint of the line around or sketching whatever other entity you might want to sketch, as you press the Tab key you can move between these virtual planes. So what I'm going to be doing now is just creating what amounts to the sweep path for the tube that I would like to generate. And I have an approximate idea of where I would like this thing to go, even though I'm creating it in its own part file. I'll be moving it into an assembly later on, and we'll get the various endpoints of the tube constrained to where we want them to be. But for the time being, let's just focus on using this 3D Sketcher to get the general layout of the tube that we want. And here, again, as you can see, I can move the endpoint of the line around. I can continually press the Tab key at any point in time if I want to change the virtual plane that I'm on and get the line going in the appropriate direction. So I'll wind it up right about here, hit my Escape key and break off the line command. And as I rotate this around, you can see the geometry that we've got so far. Obviously it is non-planar, so you can see it as a 3D sketch. Now from this point we can add some dimensions, just like you would in 2D, but there is one thing that you will want to pay attention to. A lot of times as you try to add a dimension between points, like I'm doing right now, this might work in 2D, but in 3D you're going to get the linear distance between those 2 points, and if that's not what you want, sometimes you have to take a slightly different approach. One thing that works well for me is if you show the plane, you can pick that plane along with another point, and that plane will cause the dimension to be aligned perpendicular to it, and in that way you can get the dimension and the orientation that you want. That's just one of the tricks that you use when working in a 3D sketch and trying to get your dimensions in there. Another method would be to simply dimension the line itself, like I'm doing right now, and that works just as easy, or easier actually. So we'll get the rest of the dimensions popped in here. Another aspect of the 3D Sketcher, which I haven't really utilized yet, is the ability to lock focus on a particular plane. So as you're in the 3D sketch, if you double click on a plane, you'll be able to temporarily sketch in 2D. As you can see, I can move the various geometry around as well. We can figure out what is not fully defined and so on and so forth. Let me go ahead and double click on the top plane so you can see what happens. It turns into what looks like a grid almost, and that will show you that you are indeed temporarily sketching in 2D. Everything you sketch at this point will be locked on that plane. And once you're done and you want to remove focus from that plane, double click in the background somewhere and you'll be back in the full 3D orientation, if you will. You can use a number of your various sketch tools, such as creating sketch fillets in a 3D sketch. That's what we'll do here. The technique is really no different than if you're working in 2D. You can pick the points, pop those fillets in. Of course, in 2011 we get a preview, which is nice. Alright, so there's our sketch fillets. We'll go ahead and close out of that. And of course you can double click the dimension to change its value just like you normally would with any other dimension. So there is our path. We'll use that for our sweep path in a moment. Let's close out of that sketch and hide this plane, and then next we'll create the profile for our tube, and in my case it's going to be nothing more than a circle that will plop on the right plane. We'll wind up turning this into a thin feature, which is available when creating swept or lofted features. This particular tube is going to have a diameter of 3/8 of an inch. Make sure that you close out of your last sketch whenever you're creating a swept feature. That is a requirement. Once we click on the sweep command, sweeps in their simplest form are very straightforward because all you're really doing is picking the profile and picking the path, which we'll do right here. There's my path. And then we will turn on the thin feature option just to make this a tube. This way we'll not have to worry about shelling the thing afterwards. We'll just make it a tube right now. Essentially plugging in our wall thickness, what direction we want it to go in, and accept that. So there's our tube. Here again we can just make some final changes to some dimensions. Of course, just like any other sketch, right? Rebuild incorporates the changes to the dimensions you've made and updates the model. So let's flip back to the assembly now. What we'd like to do is have this part that we've previously created move between these two connectors that I'm pointing out. So we'll bring it into our assembly. One of the first things we'll notice once we drag and drop the tube in is it's not the right size. Now I've exaggerated this to some extent. Forgot to save the tube first, so I'll make sure I go ahead and do that. And once I bring this into the assembly, you'll see that it is drastically larger than what we want it to be, which just kind of illustrates the issue that, well, obviously if you're trying to create a part outside of the assembly, sometimes it's difficult to get the measurements just so. Kind of goes with the territory. That's okay. We'll see how we can remedy that situation right here. Let's get it mated into position first of all. We'll put a concentric mate in here. We'll do a distance mate as well. Using my select other option to be able to pick that hidden face. Get that distance mate in and flip the dimension to the other side so the tube is looking like it's about 1/4 of an inch or so inside the bulkhead connector. And as we zoom out a bit, we can see that the other end is now the issue. How are we going to get this other end of this tube into the proper position? The ability to edit the tube right here in the context of our assembly is what makes this much easier. Once I edit the tube, one of our options that we have the ability to control is whether everything else that we're not editing is transparent or opaque. Now in this first screenshot you can see that everything is transparent. That's going to make it a little more difficult to work with, so what I've gone ahead and done is change that setting. It's going to be in your system options in the display preferences. And I've also changed the dimensions on this tube just to bring it in a little closer to what it needs to be. And you can see how that's done right here. Double clicking on the dimensions allows you to change them in the context of the assembly just like you would in the model itself. So we can make any alterations we need to in order to get this tube a little closer to where we want it to be. And you can also see that I've set the display preferences to show everything as opaque as opposed to transparent, which is going to make it much easier to see things and select things that we need to while working in the context of the assembly. So right now let's edit the sketch itself. In order to be able to get the end of this path where we want it, we're going to have to either get rid of some dimensions, or in my case, I'll set them to driven instead. That way they'll still come into the drawing when we want to bring the tube in and show it in an engineering layout and have those model items come in. I'll set a total of 3 dimensions to driven. That'll give me a little more freedom to move the end of this tube around, the end of the path, as you can see here. All right, we'll pull the end down a little bit. Now it has a little bit more freedom. So at this stage we can add a relationship. Let the geometric relations work for you. We want this to be centered on the connector and possibly 1/4 of an inch inside the connector. So let's get the concentric relationship added in there first. That lines up everything perfectly for us, as you can see. And then maybe next we'll get a distance dimension in there. Here again we are working in 3D, so I'm picking the face, which is going to help me align that dimension correctly. And we'll just go with 1/4 inch there. That's pretty much it. So this part that we created outside of the assembly, we were able to bring into the assembly, mate one end in position, remove some of the dimensions or set them to be driven to free up that other end, and then just get it mated in constrained into position by editing the sketch in the context of the assembly. Wouldn't it be easier to do all that in the assembly in the first place? Well, of course it would be. So that's what we're going to do next. I'll suppress this tube, and next let's try creating it right here in the assembly from start to finish. In order to do that, we have to create a new part right here in our assembly. So we'll go with a inch template. You do need to pick a face that you want to begin sketching on when you're starting a brand new part in the context of the assembly. But it starts us off with a 2D sketch, and we don't want that. So what I've just done is exited out of the 2D sketch, and I started a 3D sketch instead. Now you're back to your 3D sketcher. There's a couple different ways you could probably tackle this. I'm going to create a couple of short line segments and then put a spline between them. You could draw lines like I did in the previous example, all connected end to end, and then possibly put your sketch fillets in there. But just to mix things up a little bit and show you a different example, we'll do it a somewhat different way. When you're working in a 3D sketch like this, sometimes things can appear to be in a position that they're really not, so that's the case with this line here. But as I've mentioned in the past, make the geometric relations work for you. It doesn't matter if this thing is necessarily off in space a little farther than where we wanted it to be. We could try moving it, or we could just add the relationships. So I've got the line selected. I'll select this cylindrical face. We'll make them concentric. And now, yeah, it's a little lower than where I want it to be, but it's easy to drag the endpoints and reposition them at this point in time. So there is what amounts to one stub, one end of what the tube is going to be, or where the tube is, where it's going to start. Okay, so far so good. We'll put our distance dimension on here, similar to before, so we can control how far this tube is going to be embedded into this connector. If you want to dimension the length of the stub, you can. That's totally up to you. Dimensioning in 3D can be a little bit problematic because sometimes it thinks you are trying to pick a face to dimension to. So you can see here I'm going off the part so I can make sure I get that dimension in. And then I can drag it into where I want it to be after. One way to remedy that issue is pick the two endpoints instead of the line itself, because if you just pick the line and then try to place a dimension, it's going to think that the second thing that you're clicking on when you try to place it is the second thing you're dimensioning to. So that's what we'll do here. Instead, I'll pick the 2 points, and you can see it doesn't balk at me at this point. So there's our two stubs. We've got them constrained in position, we've got them dimensioned. Now we'll use the spline command. This would be similar to flexible tubing as opposed to an orthogonally bent tube that we created the first time around. You can use as many spline points as you want to. Here again though, make sure you use that tab key in order to get the wire, almost as it is right here, or spline, going in the direction that you want. This is going to be a little tricky, but there's plenty of ways that you can make this work. Drag the points around as you see fit. You can see I've got a gap there that I can free up by dragging the one endpoint over to the endpoint of the line. You can move the control points around. You can add tangency, which is what we'll do here. You can delete a spline point simply by clicking on it and pressing the delete key on your keyboard. Let's put tangency on this end, and that'll get the spline much closer to where we want it to be. Don't really need this spline point from the looks of it, so we'll get rid of that. Looking better and better as time goes by. All right, now another tool you'll have at your disposal that I like to use a lot is called the Sketcher Triad. If you were to right-click on one of these control points, you'll be able to pull up the Sketcher Triad from the menu. Once you have that up, you can drag that in the position, in the direction you want it to go in, and thereby more accurately control the position of the spline points. And then we've got the spline handles as well that we can increase or decrease the force on, and thereby control the shape of the spline that way as well. So I'd say that looks pretty good. At this stage we can close out of the sketch. If we open it up in its own window, you can see what our spline looks like. It does almost look like a wire, and you can use this for creating wires. It doesn't have to be a tube, tubes, wires, whatever. What I'll do at this point is show you a little trick that you may find quite handy. If you were to select near the endpoint of a 3D sketch, click on your sketch command, your 2D sketch command now, it will automatically create a 2D plane for you. You'll see that appear in the feature manager as soon as we exit out of the sketch. I'll just finish creating the profile. Right, there's your plane in the feature manager. You can see right above the sketch. Well, let's go to the sweep command though first and pick our profile and our path. Turn on thin feature. We'll create another 3/8 of an inch tube, diameter tube, 50 thousandths of an inch wall thickness. And there is our final tube. We'll move back to the assembly. I made the diameter 1/4 of an inch. Should have been 3/8. Easy to fix. Double click our feature. Double click the sketch in this case, and I'll just adjust that dimension to whatever it needs to be. We'll rebuild it right from here, and you can see that becomes 3/8 now. Alright, back to the top level assembly. That looks pretty good. And you can see what the other side looks like as well. Okay, so that looks pretty good, but you know, there still is an easier way to do this, and if you have the advantage of the routing add-in in SolidWorks, it does make things a lot easier, but there's a little bit of magic involved, and it is really nothing more than having routing components created ahead of time. So what we're going to do is take this connector and turn it into a routing component. In order to do this, I have to have a couple of special routing type features. They're called C points and R points, and I'm adding a point ahead of time, a sketch point in this part, and that will become an R point. Make sure you do have your routing add-in turned on before you create the R points and the C points. You won't be able to until you turn your routing add-on on. But that's been done. And in order to create this routing component, we'll open up the routing library manager, and it's the very first button right here. Routing component wizard. That's what we want. Now you've got a number of different types of routes you can create in SolidWorks. We're going to use tubing as the example. The buttons on my screen are a little bit off the bottom right corner of the screen, but I'm just clicking next. And here we have our different types of components, and in this case I want to create an adapter. Now let's use the example of a T, let's say, a threaded pipe T, and say that we want to create R points and C points. You're going to have your 3D sketch, or it could be a 2D sketch that this fitting is going to go on. The R point is where it connects to the route itself, to the sketch. The C points are where the pipes or tubes or wires are going to emanate from that fitting. So, R points, C points. You can create them in any order that you want to. We'll start out with an R point. Now here again, the R point is going to be where this connector attaches to the route itself, the route being your 2D or your 3D sketch. We're going to pick this point that I'd created ahead of time, and that becomes the R point. It's that easy. Now the C points have a little bit more to them, and some fittings, like the T that we saw a moment ago, would have 3 C points. This one can have 2. I'm just going to create 1. But the C point that we want to create is going to be for tubes. Now you need to make sure you pick the type of material that's going to be coming out of here. Not necessarily material, but is it going to be a tube? Is it going to be wire or whatever? So we've got that selected from the drop-down list. Now we need to specify some face that's going to dictate how that tube emanates from the part. So just using this one cylindrical or circular face is enough to tell SolidWorks that's where we want the C point to be. Depending on the type of connector it is, you might have to pick different items. The other values that I'm plugging in here aren't real critical. Usually you can just accept the defaults and go with the flow on those. The stub length is nothing more than the length that's going to come out of the connector. That can be changed after the fact anyway. So we're just going to leave that one C point in there, and as you can see here in the red, that's the other C point that I could be adding, but I'm not going to worry about it. Now the axis of rotation is typically what's going to dictate how the component is going to rotate about the route. In our particular case, it asked if we wanted to create an axis right now instead of having one that already existed. I haven't created one yet, so I'm going to go ahead and do that right now. Just going with the flow again, all part of the wizard. The axis that it shows on the right-hand side of the screen right there, the red vertical axis, is a kind of a bad representation of what you would really have on this part, so you can ignore that. So where does that leave us? Well, we're doing pretty good. It is just confirming that are we sure we don't want to create that other C point, and I'm just saying yes to that. And then what's left here is the ability to plug in custom properties for your different configurations. Now this part already had configurations, but custom properties, configurations, you might have to leave that for another lunch and learn, because those are topics unto themselves. So I'm going to continue to say next. Here's where you can give the part a name, tell it where you want to save it, and by default, in 2011 anyway, we would be saving this part in a folder called Program Data, SolidWorks. So you just have to drill down through, and then SolidWorks 2011, Design Library, Routing, Tubing in this case, and then finally probably tube fittings for this particular part. So we're all done with that. Now we have a routing component. There's our R point and our C point and our feature manager, and if we flip back to the configuration manager, you can see there are a couple of different configurations. Some of them are even different materials. The part now exists in our library, and we can drag and drop this into our assembly and make use of it. So let's move on to that. Let's take a look at how this all works out. Make sure your routing add-in is turned on. Open up your design library, drill down to wherever the components happen to be. We'll go ahead and suppress this one because we're all done with it. We could have left it there too, doesn't really matter. Matter of fact, I'm going to use these other holes anyway. One of the advantages of using this method is once you're all done adding the connectors and creating the route using the routing add-in, is the connectors are part of the route. It's a subassembly unto itself. Now here we're just telling it what we want the default configuration to be, which in this case is it contains the diameter of the tube and the wall thickness. You can choose whether or not you want a flexible route, orthogonal route. It's totally up to you. And give it a name. I just like to accept the defaults. There's the stub that you just saw there. That's the default length of the stub. Obviously can be changed. I just drag the endpoint of the line, thereby increasing the length of the stub. We're going to drop another connector in here, and we'll see that stub once again. Figure out which one I want, and then the mate references apply here. We can pick the configuration that we want for this particular connector. There's the stub. We can close out of the command and once again drag the endpoint on the stub to whatever length you want. Yes, you could dimension that as well. Now the beauty of routing is what's known as AutoRoute. At this point we can turn on AutoRoute, tell it we want to go from point A to point B. In this case we're going with an orthogonal route, and we have our choice of different different types of different configurations for this orthogonal route. Once you find the one that you want, click OK, and you're pretty much done at this point. Let's close out of the sketch, and we can go back to the top level assembly. I like to hide the sketch too. If we're all done with that route, there's no sense in leaving that visible. And this is a subassembly unto itself. So if we open that up, we can see what that looks like. So thanks for watching another episode of Lunch and Learn, brought to you by CAD Dimensions and yours truly, Dave Murray. Until next time, happy modeling.